what I always encourage students to do when they are graphing a piecewise function is I encourage them to graph each individual part of that function. Okay? So f of x equals 3x minus 1. Okay? 3x minus 1. Now for 3x minus 1, you should, this is the red graph right here. It crosses at -1, and then it has a slope of 3. So up 3 over 1. My second one is, and sometimes because there's no x in this, students get confused, it's y equals 4. It's just a horizontal line. Y equals 4. Okay? My last one is x squared, and that's the green parabola right there. Okay? So, graph all three of them on the same line, on the same graph. And that's what you did. And remember, you can use Desmos on your project. So you take a picture and you look at that. What the piecewise function tells us to do is follow a certain rule depending on the numbers that you are talking about. Okay? So, in this particular piecewise function, if my number is less than -1, if my number is less than -1, the rule that I am going to follow is 3x minus 1. Okay? So what I tend to do is I tend to draw a line, and I'm going to do it on a bigger screen. Okay? So my piecewise function says when x is less than -1. So here is -1 right here. Okay? Here's -1. Okay? So the only time I am going to follow that rule is when my value is less than -1. So less than -1 is this way, right? On the x-axis. So I am going to only follow this. And in my particular screen, I don't have it, there's not that much of it. Now, my piecewise function says x is less than -1. Is -1 included? No. How do I write on this graph that -1 is not included? What kind of dot do I put there? Open. Very good. So at -1, which is right here, I'm going to have an open dot. Really? There we go. Okay? And so sometimes it's helpful to kind of have this off to the side. So the entire rest of this red line doesn't apply. Okay? The only part that applies is down here in this less than -1 area that I've got. Okay? Now, my blue line is my second function, and it's y equals 4. So this blue line right here, that is my y equals 4. This one right here. Now, my piecewise function tells me the only time that I focus on my blue line is in between -1 and 1. -1 and 1. Now, I've already got a line at positive, or at -1. So I'm going to go ahead and make a line at +1. So the only time I follow the blue rule is in between -1 and 1. Now, we look here to determine if -1 and +1 follow that rule. So the question is -1 included for that graph? Is -1 included? Yes, tell me why. Excellent. Because of that less than or equal to, because of that line. That line underneath is why it's included. How do I mark that it's included? Good. My dot is not open. So that's the part of the graph. So all the other blue parts I don't include. I don't include any more of the blue parts. Only that part that I've drawn. Okay? Now, my third rule is x squared. Y equals x squared. I don't start following that rule until what? Until x is greater than 1. So here's my green. So I'm going to have an open dot right there. And then this is the rest of my function. Okay? Now, it's crowded. So you've got to rewrite this. Okay? You've got to rewrite this from your Desmos. But this is what's happening. You've got to decide during what time do you follow which rule. So whenever you do a piecewise function, the very first thing I tell students to do is graph all three functions on the same graph and then pick the pieces that you need. Okay, so now I have I'm going to draw okay? And I often think it's easier to do this in certain colors. So, what point is this right here? It's -1 what?
-4.
-4. Okay? So at -1, -4, I'm going to have an open dot. What was my slope for that? 3. Okay? So if I go down 3 and over 1, down 3 and over 1, that is -3 over -1. Does that fit a positive slope? -3 over -1. Yes. Okay? There you go. Okay? Now, my blue part of my line, okay, it's at y equals 4 in between 1 and -1, or -1 and 1. So here we go. And I've got closed dot. Whoops, that's not 4, is it? I need to go up to what? What do I need to go up to? 4. So here we go. Okay. Why do I have the dots there? Because of the equal to. Okay, do you see this? That's where your or equal to's are. Wherever you've got the or equal to's, that's the graph that has the closed dots. Then, my green, I start right here at 1, 1. Okay? And it is an open dot. Okay? And then here, there we go. What are these called? What are these called? Piecewise functions. Okay, so if you need more help on piecewise functions, this is from chapter 2. Okay, piecewise functions is what you want to look for. Okay, and this and I know I asked you to graph this when you came in, this is what the original problem would look like. That's what it looks like on your project. And I think it's numbers 3 and 4 on your project. I'm not 100% sure. But I think that's what it is, numbers 3 and 4. So you take the 3x minus 1 and you think of it as y equals 3x minus 1. The f of x equals 4, think of it as y equals 4. F of x equals x squared, think of it as y equals x squared. Okay? Any questions or anything on that? Okay, I did record this.